Hey guys, let's get started studying for our unit test. So this first question is asking, is triangle RAP, is triangle RAP similar to triangle NOK? And why? So if you remember, similar shapes are going to have all the same angles, but they are not going to have the same side length, but the side length will be proportional. And on page 120, if you want to go back, if you can't find your own notes in your notebook, on page 120 are the notes on similar triangle, oops, forgot my I, triangle theorems. Okay, so that's, whenever it's asking you why, it's either asking you for a similarity triangle theorem or a congruent triangle theorem for this chapter in this test. So here, what we can tell, if we want to find the ratio, I'm going to ask myself from RAP, is 6/9 equal to 9/15? And if it is, then the sides of the triangle have the same proportion, and they would be similar because in the middle, they both have a 90-degree angle in the middle of those two sides. So 6/9 reduces down to 2/3. And is that the same thing as 9/15? I think 3 can go into both of those and it becomes 3/5. Okay? And 2/3 is not the same as 3/5. So they are not equal to each other. So they are not similar. They are not similar because they have the proportion of their sides are different. The proportion of their sides is different. Okay, so those are not. They are not similar. Let's go down to the next one. Is triangle RAM similar to YAK? So let's take a look. Well, what do we know? We know that triangle A is the same, or I'm sorry, angle A is the same for both triangles. We have a larger triangle, and I'll do that one in yellow here, right? This is the large triangle. And the smaller triangle, we have a smaller triangle in, let me make this extra thin. And we have a smaller triangle kind of on the inside of that. And they share that angle A, right? So they already have one angle in common. And then the other thing we know is that these two sides here are parallel, and what that means is we can use all of our prior information about angle pair relationships to figure some things out. So if we have parallel lines and a transversal, and let's say this line on the top is one of our transversals, it is, then our corresponding angles are the same. So those two are the same. And they actually, it's the same on the other side also, not with each other, but these two angles are the same and these two angles are the same. So we know at least 2 are, and actually as long as 2 are, all 3 are the same, right? So they are similar. Similar because of angle theorem, similarity theorem. Similarity theorem. Okay? No math required. Well, some logical thinking, but no actual number math required. Okay, here, what is the value of Q and R in each diagram? So this is cool. Let's take a look. In this diagram here, I know that these angles are congruent because they are vertical angles, right? And then it's also telling me that this side is parallel to here, so 9 and R are parallel to each other. So that means if those two lines are parallel to each other, that means that if we look at just this line here, if we look at just this line that goes all the way from here to here as a transversal, then these two angles are on the opposite side and they're on the interior. So they're alternate interior angles. So now we have at least 2 angles that are the same in these triangles, and that means by default the other angle has to be the same also. So we can use the fact that these are similar triangles to find the side lengths because they should be proportional. Now, here's one of the important things we need to talk about. We need to know that you have to use corresponding sides. So in this case, because 4 is between those 2 angles that we set up, and because Q is between those 2 angles we set up, we know they correspond together. We know 9 corresponds to R, and we know, oh, this might be a little bit too thick, and we know that, whoops, it's not what I wanted to do. And we know that 6 corresponds with 5. So now we can set up some proportions. So we know 6 over 5 is equal to, and then since I started with this triangle here, I need to start with it here, 4 over Q, and that's the equation I'm going to use to solve for Q, or that's the proportion I'm going to use to solve for Q. And we also know I'm going to use 6 over 5 again, since I have both of those numbers, is equal to, and since I used 6 first on the numerator, I'm going to put 9 on the numerator, 9 over R. So you can do these 2 different ways, and I will do one of these each way. The way that we always learned in algebra is to multiply both sides by both denominators. So times 5 and times Q, and this side also times 5 and times Q. So what happens here is these 5's cancel out, but on this side the Q's cancel out. And now what I have is 6 times Q is equal to 20. Then we divide both sides by 6, and we get Q is equal to 3. 6 can go into 23 times, and that's 18, right? And then how many is left over? 2/6, right? And that's the same as 3 1/3. And if you put it into the calculator, instead of doing it by hand, you will get 3.33 repeating. Okay? A lot of the questions on the test are multiple choice, so you need to be able to tell that 3 1/3 and 3.33 repeating are the same thing. Okay, and now on the other side, I'll use a different strategy. I'll do cross multiplication. So here we take, like this, we're going to multiply this way. So 6 times R is 6R is equal to 5 times 9 is 45. And then all we have to do here is divide both sides by 6 again. And R is equal to 6 can go into 45 7 times. 7 times 6 is 42, and we have 3 left over, so we have 3/6. So that means R is the same as 7 1/2. And if you use the calculator, you probably got R is equal to 7.5. So our 2 answers here are Q is 3 1/3, and R is 7.5. Okay, whoops. Where did we go? Where do we go from here? Okay, in the figure at the right, BD is parallel to AE. So let's take a look at this. BD is parallel to AE. So that means we can use all of those angled pair relationships. They share this, and then these are the same, and the other side's the same, which means they're similar because of angle. But the only reason we can tell that is because we knew that these sides were parallel. And then it says if BC is 6, if AB is 8, and AE is 9, what is BD? That's my X right here, right? So we have some proportions we can set up. Now, here is the mistake that the test thinks you are going to make. They think you are going to say 6 over X is equal to 8 over 9. Okay, but you guys, it doesn't understand that you guys know better than that and that you've learned better than that. And instead of 8, when we're talking about the larger triangle, 8 is not the side length of the larger triangle. The side length of the larger triangle is 8 plus 6. So it's not 8 on the numerator, it's actually 8 plus 6, which is 14. Okay? Now we can solve, and we'll multiply x. Let's cross multiply. X times 14 will give us 14x is equal to, and 6 times 9 is 54. So divide both sides by 14, and you get x is equal to, I don't know, how many times can 14 go into 54? 3? Let's check. 14 times 3, that's 12, carry your 1, 3, 4. 42. What about what is times 4? Is 16, carry your 1, 4, 5. 56, only 3 times with a remainder of what, 12? Watch my math. If I make a mistake and you catch it, I'll give you an extra credit point. 12 over 14, which reduces down to 3, half of 12 is 6, half of 14 is 7. 3 and 6/7. Let's see if that matches what we would get with the calculator. So in the calculator, if I put in 12 over 14, whoops, divided by 14, okay, I get this decimal, but check this out, guys. If I just want to reduce it, I can check it by hitting the math button, and then 1 says fraction right here, so I'm going to just hit enter, and I want to turn it into a fraction, and it says 6/7, and it will always give you the lowest fraction. So my 3 is still correct. It's 3 and 6/7. I could have also have done 54 divided by 14, and that's going to be 3.8571, and you can see this 8571 is the same as that 12 divided by 14, so we're correct there. Yay, so that was a weird one. Don't freak out if you don't get perfect answers, okay? All right, I think I have enough time to do one more problem here left in my video. So if ABCD, if quadrilateral ABCD is similar to quadrilateral KGHJ, find the value of x. So it's really important here to remember your corresponding sides, and it's written that way. So if this is AB and it corresponds to KG, that means this would be a green side and KG would be a green side. And let's see, then we have HJ corresponds to CD, and then that's this side and this side. So if you are making your proportions, you could do this either way. You could say, you could use them from the same triangle, and you could say 8/4 has to be equal to, and then use corresponding sides. So if yellow goes on the numerator, then yellow on this one has to go on the numerator, x/20, okay? Or you could do, you could figure out from the different quadrilaterals. So we could set up another one and we'll get the same answer. That's 8/x is equal to 4/20. Okay, and if we solve them both, we should get the same thing. So here, if we cross multiply, we get 4x equals 8 times 20 is 160. If we divide both sides by x, we should get 40. Okay, and on this side, we get 4x equals, and then 8 times 20, 160, so we get the exact same thing, so x has to be 40. So it doesn't matter which way you do it. You could have also thought about it as like, to get from 4 to 20, I need to multiply by 5. And up here, to get from 8 to x, I need to multiply by 5. So if I multiply 8 by 5, I get 20. Checking your work is always going above and beyond. All right, check out the next video for the rest of the answers.